Um, Welcome everyone to this session on bringing together the AI and Earth observation communities. Let me just show you what we have on the agenda today. So well, we've started this a little bit, or we're adding in here a little bit about the AI for EO initiative from ESA's Phi-lab. We'll be showing you later an award ceremony and talk about some upcoming challenges. But before we do that, we also are connected to some other initiatives that are also working on ways of bringing AI into Earth observation or getting those two communities closer together. So we have Andrew Fleming here of the British Antarctic Survey, who is going to speak about AI for the study of environmental risks. And we have Michele Lazzarini from the EU Satellite Center, who is going to talk about the AI for Copernicus. Two very exciting initiatives, which all of our AI for EO participants can also benefit from. For any of the questions that you may have during the session, put them in the chat, and then we'll bring them up either after the end of the presentation or at the end of the session, so we can answer your questions. With that, I will leave the floor to Andrew. I'll stop sharing. Yes. If you're speaking, I'm not hearing you. Not yet.
Ah, that was the bit.
Oh, there you are. Thanks.
Okay, finally, can you hear me?
Yes, perfect.
Good. Okay, thank you. So thank you, Anna-Katrine, and thanks for the opportunity as well. So I'm going to give a very quick overview of a project that we're running with ESA, which is called the AI for EO Accelerator, but relates to a range of activities that are summarized here. So I'm talking about a project jointly between the British Antarctic Survey, University of Cambridge and European Space Agency. It relates to a Centre for Doctoral Training called AI for ER, which are Artificial Intelligence for Environmental Risk. And the scope of the activity is to develop a framework whereby we bring together new AI and Earth observation approaches, methodologies to address new or critical environmental challenges. So we're not alone in this. There are a large number of partners part of the associated with the AI for ER CDT. A number of them are listed at the bottom there, the logos included. And those are the ones that have been involved in the first set of the team challenges. And it's these team challenges that I'm going to outline for you as the main part of this activity. They're not the only partners in the CDT. There's a long list of them, and they are potentially involved in future activities. But this is just to give you an indication of the sort of people involved in this this Centre for Doctoral Training and where some of the ideas and the projects behind these team challenges come from. So what do I mean by team challenges or challenge sprints? So effectively, it's a focus period of activity that the students in the Centre for Doctoral Training participate in as part of their studies. They work in teams and they complete a focused bit of research on a particular topic over a period of 3 to 4 months. So far we've run 2 of these, 2 research sprints completed, in 2 of them in parallel last year. They start roughly in December, end at the end of March. And the ideas for the topic that they address come from the partners that I've just referred to. And we have an associated group that then helps to filter the ideas that are proposed and focuses the question that the students address and research. So we, through a series of thematic workshops, then refine that question so that it's specific enough and they have the right data and tools and they know where they're going. And then they have a range of contact throughout the sprint period, both with the partners to answer questions and then also with academic mentors so that to keep them on track and make sure they have access to the right academic skills and to allow them to complete this. I just point out that even after the first 2 sprints, we've had very, very good feedback, both from the CDT partners. They feel like they've got something really useful for their work and answers to the questions. Also from the challenge expert group in terms of the experts that define the question. But it's also hugely beneficial for the students as well. They're very positive. I mean, in effect, they get some very real world experience of answering a question that is defined by non-academic experts often in the commercial sector. They're having to answer to real requirements and then present it and present their answers themselves. So it's been very positive all around. So the broad pattern of setting up these challenges is, as I said, we have a challenge expert group. So it's a grouping of expertise in this area. They include some of the partners who propose topics. Those topics are set out as a broad area, and then they're refined through subsequent thematic workshops with some expertise associated with those questions. And then we get a challenge question that's put to the students. And towards the end of this chain, the student teams are brought in and introduced to the topic, and they have a chance to start asking questions about specifically what are you interested in. They're often very new to the topic, so they get a chance to be familiar with that and what data is available, tools are available, and really understand the question that's being asked. So I mentioned that there were 2 challenges completed so far, one of them on biodiversity, specifically habitat fragmentation, and the second one on exposure of informal settlements to risk, to natural hazards, really. And I'll give you a little bit more detail about what they covered. So this next couple of slides just give you some details of what was achieved or addressed within the risk exposure group. So they were looking at informal settlements, or settlements that are often unaccounted for by local governments. They don't know they're there, and then how exposed they are to natural hazards and being able to identify change. So we're talking about settlements that nobody's really sure the extent and location of. So challenge 1, can those be identified? And then secondly, challenge 2, can we automatically pick up changes after some sort of natural hazard event? So this group approached this with a range of different methods, and certainly made some progress, but absolutely ran into a key limitation in that the data set they were using was primarily Sentinel-2, and the resolution issue was a real showstopper for them at some level. So good success with tests on much higher resolution, and that's where that's likely to head to next. The other topic addressed habitat fragmentation. So looking at the complexity of a habitat, looking at using graphing methods to map the connectivity of that habitat, and then options of being able to track that the changes in fragmentation of a habitat over time. And some examples show you in those 3 in the triptych there, show you the imagery, the habitat classification that was used, and then the graphing in terms of being able to then map connectivity of similar habitat types. This has actually now been implemented. The students implemented this as a geograph package, and this is the interface to it that you can see. So you can take some of the imagery, classify the habitat, and then understand the fragmentation and how that's changing. And of course, this has got real-world application, and WCMC, etc., are keen to continue using this. It gives really key insights into things like identifying potential conservation areas or bits of habitat that are a particular risk or isolated, and then also flagging where habitat may be at risk of fragmenting, and being able to put in policy or mitigation measures to prevent that. So those are the very brief descriptions of both of the first two challenges. But if you're interested in any more detail, then it's all online at these links. There's a main project page, but then a separate page for each one of the two challenges. And it's not just a high-level description. You can access the data used. There's a link to the code and a working example, and everything that would allow you to understand all of it, and contact points back to the people that were involved, if you wish to follow that up. And so the aim subsequently will be to expand the number of challenges that are published on here, and increase the portfolio, working with other partners to define new questions, new challenge topics. As a little bit of an aside, within this project, in addition to the team challenges that we ran, we did also have a task to try and look at understanding the wider ecosystem around the AI and EO sector. So not just looking at the partners involved within the CDT that we've been working with, but beyond that, how do we find researchers or expertise within a particular domain if somebody was trying to address that. So rather than just come up with a high-level description of, yes, here's a list of companies involved, and here's a list of research groups, and here's a list of software packages, etc., which would have been out of date within 5 minutes of the ink drying on the document, given the rate of change in this area at the moment. We actually started looking at trying to automatically map this, so in effect use some degree of AI for mapping the sector or the ecosystem. So using published libraries of publications and grant awards and that sort of thing to see if we could map this. So we've only taken this to a proof of concept stage, and to a degree it works, but to expand it and scale it up would be a next stage that requires a bit more resource. But the initial concept, at least on limited input like Web of Science and Google Scholar, etc., gives us pretty good positive results. So more to come on that in the future. So last slide, and then I'll wrap up. So next steps and where are we going to? So there are 2 more challenges that will start with the next round of students. So they will they're being defined at the moment. The definition process has started already, and they will start in December and then complete in March 2022. So this time round, we've been talking to some of the partners, and the topics are not yet selected, but it's likely that we're going to work more closely with some of the folk in ESA Philab, and then also some colleagues in BAS. There are a couple of cryosphere themes that are coming up to the fore. So at the moment, those are the candidates, but we'll define those in the next month or so before the students start. There are also 2 potential further years within the AI for ER CDT. So we're keen to enable the similar team challenges to be set up for them. And then it's really a question of the ambition to scale this further. We know that other partners within AI for ER are keen to participate in these challenges and suggest topics. And then beyond that, there's also an ambition and some appetite for using a similar model for these team challenges within universities, within other training opportunities, to use the same sort of model of having externally defined real-world challenges as a focus for these student-led activities. So I will end there. Thank you very much indeed. Happy to take any questions.
Thank you, Andrew. Indeed, some questions have come in already, but perhaps with your last slide, you answered already one of them. Is AI for ER focusing on students, or is it open to anyone?
At the moment, it's focused on the. Let me just see if I can stop this sharing and then come back to me. Yes, at the moment, it's focused on the students within the CDT. So those are the people that are involved in the challenges. The topic definition comes from the partners within the CDT as well at the moment. But there's no reason, and that's what I was kind of getting at the end, as you've highlighted, that a different version of this can involve any setup.
Another question was whether you have done the ecosystem analysis. I know we have spoken about it already, and a very related question came in. Do you think having an AI for EO community platform is relevant?
Do I think a community platform is relevant? Why regarding the ecosystem analysis specifically? Oh, sorry, that ecosystem analysis. Sorry, I'm back in biodiversity ecosystems analysis. Yes, so I think it absolutely so it fits really well with that. If you're going to have a platform that's going to either be a feed into such an automatic analysis, then that's one route around. But I would have thought that a community platform is also looking to glean information from that sort of analysis of who's working in ecosystem fragmentation using Sentinel-2 imagery and this sort of methodology. Having something like that would be something that community, that sort of question I can imagine that community wanting to answer and find the right people.
And then the last question is, are you looking for challenges from third parties?
Why not? Suggest a way. I mean, I think at the moment we have a route to defining the challenges for the next set of sprints, which will happen this year, but they're not set yet. So happy to discuss. Yeah, please email me.
And perhaps I'll add to that on AI for EO, which is less research focused, but which also organizes challenges. We are open to third-party challenges as well, as I'll show you here in a little bit. Thank you very much, Andrew, for the presentation, for being here. And then we'll go over to the business side of AI and Earth observation, in particular Copernicus, with a presentation on AI for Copernicus from Michele Lazzarini.
Hello, can you see me, hear me?
Yes, both.
Okay,
perfect.
Great. So I'm gonna share presentation. Can you see the presentation as well?
Yes. Yeah.
Great. So thank you. It's a pleasure to be here today. Just minimize this window 1 second. It's gonna cover me the presentation. Okay. I'm here on the behalf of the AI for Copernicus consortium. I'm Michele Lazzarini. I'm a project manager for the Research, Technology Development Innovation Unit at the European Union Satellite Center. The presentation aims to present the AI for Copernicus project, and now this project aims to bridge the AI community and the Earth observation community. So just a few words on the European Union Satellite Center. We are an agency of the European Union Council. We support the European Union in the field of the common foreign security policy, analyzing data from space-based assets. In particular, our unit is a research innovation unit working on different topics. These are the main 5 streams of our work. Exploring new data sources, Earth observation sources, of course, but not only, also from satellite and from aerial system like apps. We also work in the GovSatcom area to shape the new GovSatcom capabilities for Europe. Of course, innovation technology like artificial intelligence and big data. mainly to provide Earth observation application, and also cooperation is a very important part of our unit activity. You can see here the project where we have been involved in the last 6 years. Maybe some of you are also partner. Actually, I saw in the audience before Grega and Mattei from Synergize. Synergize is the coordinator of a global Earth monitor project, another project we are taking part of. You can see here in the timeline. So let's go directly to the project. AI for Copernicus is an H2020 project. It lasts 3 years. It started January of this year, actually 2021. And the title is actually self-explanatory. The aim of the project is to reinforce the AI4U platform by advancing Earth observation intelligence, innovation, and adoption. I suggest you to also check your website because there are many interesting information, especially about funding. We have a project where we actually we manage open calls for external entities. So there are always some initiatives going on. As again, have a look at the website to have more information about this point. The project partner consortium, the coordinator is Demokritos from Greece. You can see here we are trying with our consortium to cover the different aspects required for this project. We have a Earth observation expert, the AI expert, then of course we have the technological partners to support in the development of the infrastructure, and regarding the also the users, we have 4 domains represented in the consortium. We, the European Satellite Center, will represent the domain of security. We have a CNWF, of course, mainly related to weather forecast and health. Equinor for Norway, representing the energy domain. And then we have University of Trento representing the agriculture domain. Plus, of course, it's very important because, as I said before, we are trying to bridge the Earth observation world with the AI world to have a representative for the Earth observation main infrastructure. We are this infrastructure, of course, the diocese. So we have Cloudferro from Poland representing Claudias, and also Thales for Wikeo. Plus, we have Blue Site from France and Thales Alenia Space for other tasks like sustainability of supporting the development of algorithm. So AI for Copernicus is probably you heard one of this project, the AI4U. AI4U is a very big project. It's gonna 20 million project. It's gonna end this year. The aim of AI4U aims to be a one-stop shop for AI methods, dataset, and community in Europe. On the other side, you have the diocese, which represent basically the main entrance for access and our Earth observation data, of course, in particular Sentinel's data, and also to provide also processing capabilities. So the idea of AI for Copernicus is trying to match these 2 platforms, so providing the access to satellite data and also to the tool of available in the AI4U platform. So you can see here, giving you a bit of a context, is both AI4U, AI for Copernicus are 2 European Union initiatives, 2 projects from the ICT 48 for AI4U. And you can see the different initiatives that are involved in the AI4U. And from the other side, the ICT 49 projects, who had the aim to develop some additional services on connecting to this AI4U. Of course, you can see AI4U, AI for Copernicus on the right side was the aim to connect the Earth observation world, but you have also other domains like, for instance, energy. And going to the objective of AI for Copernicus, there is like a technical integration, so integrating these 2 infrastructure, AI4U and diocese, offering also additional services for innovation. What we gonna see in a few slides is actually maybe the most interesting part of the project. This is the AI Earth observation innovation cycle via open calls. 4 rounds of a call are conducted. leading to 17 AI and AO solution and 2 citizen-driven societal challenges, and also support the evolution, uptake, and impact of all the related platform. As I said before, we have directly in the consortium 2 partners involved, Creodias and Wikeo, but also we aim to involve Mundi and Soblo in the evolution of the project and the connection between this with the AI4U platform. Again, just to, if you want to have some more information, you will see that we have a AI4U catalog and search, and Acomos, which is the, let's say, the platform experiment for artificial intelligence provided from AI4EU world. And then we have the diocese on the other side, of course, also connected to the data access of a Copernicus Data Access Hub. What I would like to talk a bit more, because maybe some of you will also apply to the first round of calls, but you are interested to apply to the other rounds of call. The idea with this open calls, it bridges the gap between AI and data-driven innovation, facilitating value-driven co-creation among diverse user group and communities. So, in particular, what we would like to have is fostering a small, medium enterprise from Europe to provide new ideas, new solutions, new applications that are merging the artificial intelligence and Earth observation. So we have 2 million funding available in different batches, and the idea is like to provide this kind of solution that can be also useful later on after the end of the project. The first call was, let's say, driven by us in the project, by the 4 industrial domain represented in the project. Just to remind you, they are agriculture, energy, security, and health. The call just closed a couple of weeks ago, 30th of September. Now we are in the evaluation of these calls. There is now the open call for citizen societal challenges open. It's more than a call. I will call it an award, because as you can see, just 5K. So it's for an individual idea from a single citizen. The interesting thing is that this idea will be then developed in a frame of a project in the 4th round of the call. You can see in the bottom right. So based on this idea of a citizen, we will have another batch of a call where the small, medium enterprise and the consortium can apply and develop this idea from a single citizen. And then there is also this 3rd batch of a call, 80K. In this case, we are not limited to the industrial domain represented in the project, but it's more open also to other industrial domain. Again, as I said, I will tell you also a couple of words more about this first batch of open call, because maybe some of you applied and you want to know more information about the actual number of applicants. So the idea is now we are going in the evaluation of the calls. The winner will be selected in December. The idea is to select until 6 projects with a funding that it goes between 120K to 150K according to the dimension of the consortium. And the project will be developed from January 2022 to April 2023. What is important to say that is we as a domain in the project, we support also the winners of a bid during the development of a project, meaning that we provide some services. For instance, we as a security domain, we provide the preprocessing services to create analysis ready data from Sentinel-1 and Sentinel-2 data in order to, let's say, to reduce the amount of work of the bidders in this phase and to focus on the creation of innovative application using artificial intelligence. So, and of course, we provide the platform for you to develop these services, which can be either AI4U instances or the DIAS instances according of what you are interested to provide. As I said, this is actually the 3rd one. Open calls for experiment will be open in a period between January and April. In this case, we are not limited to the 4 domain that you can see on the left, but is open to any industrial domain. will fund up to 8 projects. What is open now is going to close in October. So if you as a single citizen has some interesting idea about the use of artificial intelligence observation, I suggest you to have a look to the website and see how you can apply. I think if I remember correctly, the application is a couple of pages, so it doesn't really take a lot to apply for this. And then, as I said before, these ideas will be developed in a second stage later the next year, and when we will fund up to 3 projects based on this citizen-driven societal team. Some number regarding the first open call submission status. We received 34 proposals, which is quite a high number. We were expecting, to be honest, a little less, so we are happy to have to receive this amount. The proposal divided in as you can see in the screen. So we as security received 10, agricultural 13, energy 7, health 4. As I said before, the idea was to have a small consortium because the amount of money was around 120K for 2 partner consortia and 150 for 3 partner consortia. You can see there are like 60-40 as the say distribution of the consortia. And now, as I said, we are in the selection phase. And the grant agreement will be signed at the end of the year or the beginning of the next year. So, and then we will enter in the support phase, the sustain phase for the rest of the project. And as I said, as Anne-Catherine mentioned before, this is probably an interesting opportunity also for IE4AO world. If you have some idea where you can submit for the challenges that we have in our project. Thank you. This is my last slide. Again, this is the web page for the project. Please have a look for that if you have if you want to have any information. Please also drop us an email if you want to know something more about the project. Thank you.
Thank you, Michele. Indeed, for any of our AI4EO participants, AI for Copernicus can be a very interesting way to continue your project, to continue developing it into something more, something sustainable, a sustainable company. So we highly encourage, we also include AI for Copernicus in our prize catalog, which is part of our prizes for the winning teams. And I believe it's time to announce our winning teams of the second AI4EO challenge, which ended 2 weeks ago. Our several teams have spent 3 months working really hard on developing a solution for enhancing Sentinel-2 for land management purposes, extracting features from Sentinel-2 imagery at a higher resolution than what is feasible or what is offered by Sentinel-2. And I leave the floor to Nicolas to show who were the final winning teams of our second challenge.
Okay, I hope that you see full screen, right?
Yes.
Okay, perfect. Yeah, thanks, Anne-Catherine. Indeed, I mean, this is the time to announce the winner for this second AI4EO challenge. I mean, yes, as Anne-Catherine already mentioned, I mean, this challenge was about to be able to detect Arabelle lands at 2.5 meters, starting from Sentinel-2 data at 10 meters. So integrating as much as possible at the great and consistent time series that we can get from Sentinel-2 data. In a sense, it was some kind of a super resolution problem, but with the idea to go really up straight to the super resolved thematic product. It has been a very exciting 4 or 3 months where actually many teams registered, look at the data, played with it, and submitted some nice solutions for this challenge. So I think that we had almost 100 teams registering, and among of them 17 teams were very active. And actually, the fight for the first place was great. We could notice very active participants among the top rank teams close to the deadline, so trying to improve their score by a few tenths. So it was great. I will not be able to reveal all the secrets from the various submissions, but clearly for this second challenge, we had very great submission. We have in fact collected a set of very interesting approach with state-of-the-art methodology based on, for example, permutation invariants and intensities, residual attention model, super-res conditional GANs, and also more well-known, let's say, old techniques like super-res ResNet or UNet. But still, it was very interesting. So here, the top 3 teams and their members will actually receive some AI for AO points, which can be used to pick some prices. It will be on the first come, first serve. So starting with the first one, second, and then third prize. For this challenge, as Platinum member, we had the kind contribution from S3RS, offering 2 years of access of NV, but also classroom for training on NV and Starscape. As a gold sponsor, we had Planet offering as a price data in a value of up to 15,000 euro from Planet Archive. So many thanks for these 2 companies and these contributions. Not to forget also all the other vouchers for scientists, technical and business consultation from all the experts that you can see here with the logos. And we have also Darius, Wikio, Claudius, and definitely many thanks to all of you. So I like also to remind that the final ranking is actually based on two aspects. One is the quantitative leaderboards, but also we had a jury that evaluated actually the quality of the codes, the relevance of the solutions, and so on. So it's kind of a mix of the two. Okay. Without any further ado, then I think it's start with a surprise, which actually will be given to teams Eagle Eyes. So congratulations to this team. Actually, the team is from the German Center, German Climate Computing Center, DKI RZ, which is composed of Dr. Frocke Albert and Dr. Caroline Arnold. So both Frocke and Caroline are both data scientists. So I don't know if you are in the room or if you like to say some few words on yourself and the proposed solution. You may have some few minutes to present what you are and eventually your solution. So please. I don't know if you
Hello.
can. Yep.
Can you hear us?
Yeah, we do. Please go
Great.
ahead.
First, yeah, we are really excited that we made the 3rd place. I think it was very close. We submitted something in the very last minute or last hour of the competition. So our approach used a super resolution network. It's actually part of a GAN, so of a generative adversarial network, but we skipped the discriminator part and just used the generator part. And we basically just stacked as much data as possible together and put it through the super resolution. And yeah, we did not explicitly treat the time dimension of the problem. We rather composed an input where we stacked all the different time frames on top of each other and then let the network decide on its own. Maybe Frauke, you want to add something?
No, I think that was a good explanation. Thanks.
Okay, thanks for this brief explanation. I hope that, or I guess that we'll have the chance to read your paper on this experience and your model that you built for this challenge. We look forward to that. Let's move to the second place then, which goes to Team TCSA AI. Actually, this is some kind of well-known to us because they won, I guess, the 3rd prize for the last challenge that we had. So this team is composed of researcher engineers from Turacasa, which is a public company in Navarra, Spain. So we have Christian, which is who is a machine learning engineer at Trocasa. We have also Javier, a data scientist, and we have also Christian working as a software engineer. So many thanks to the three of you. And again, if you'd like to say some few words on yourself and the solution that you propose, that would be great.
Hello, can you hear me?
Yeah, we do.
Okay, first of all, we want to thank you all for organizing this challenge. We have been working very hard during these last 3 months. And finally, we have come to an approach that has permitted us to achieve the second place. This approach is mainly based on a UNet network, which is modified at the input in order to increase the resolution of the images 4 times, just the same resolution as the one that we want to get at the output. And this network fuses some hypertemporal information, not only the standard frame information, the bands, but also some statistics such as the interquartile range and the mean and standard deviation of these bands across a fixed time interval of, I think, 19 time steps. And this information is mixed in the backbone of the network and passed through the decoder in order to reconstruct this segmentation mask with these cultives.
Okay, clear. Many thanks for this explanation. Again, I mean, the leaderboard was, I mean, it was very crazy on the last days, and we scored, which was very close altogether. So it's this second place is well deserved to you, Trocasa team. Many thanks to you for participating again. So I guess now it's time to move on the first place. This works. Yeah. So I cannot really feel the suspense in the call here, but I guess that probably you know already who will be for the first place, and indeed this is the one that actually top rank the quantitative part. So thanks to the IPL team, and actually this team actually is a single guys. Is composed with Diego Valesia, who actually is from Politecnico di Torino in Italy, and his main research interests include computation, remote sensing, machine learning. So I guess, I mean, first of all, many thanks, congratulations. So you won this 30,000 points that you can use as you wish. You are the first one on the list to pick your own price. Would you so I guess as you are the winner, you may have an extensive time to present yourself. You can have like 5 minutes if you like to present your solution yourself, and it's up to you. Please go ahead.
Okay, thank you very much, and thank you for the very interesting challenge. It was really well put together. So let me see if I can share a couple of slides. So do you see my screen?
Yeah, we do.
Okay, so basically what I'm going to present about my solution is a new idea to deal with multi-temporal data and deep learning models. So the idea, let me go one step at a time. So we know that we're trying to solve a super resolution problem with multiple images. And this is a very hot research area right now, especially since ESA promoted this super resolution challenge on the PROBA-V satellite. And there are a number of state-of-the-art methods like DeepSum, which is actually our earlier work on the PROBA-V challenge, that introduces some interesting idea like dynamic registration filters. There's this high-res network also from the PROBA-V challenge, which had this idea of using recursive fusion approaches. And then there is this RAMS model, which largely used feature attention. And then there are some works coming out in the very closely related field of burst computation photography, so from bursts of photos. However, there is a problem because none of these state-of-the-art methods address an important issue. And the issue is that the temporal ordering of your multitemporal images does not matter. So if I permute the temporal ordering of my low-resolution images, I should always get the same super-resolved image. So the ordering does not matter. So we need to build models that are fully invariant to temporal permutation, which means that the model should produce exactly the same output, no matter the temporal permutation of the input. And this is not the case for existing models. As a matter of fact, if you try existing models with different permutations, you get different results. And if you average them, your performance improves. But this is clearly not efficient, and it's very expensive to do. So you want this power to be directly inside your model. So how do you build an invariant model? Well, you build that, first of all, by using equivariant operations. So every layer that you put in your neural network should have this equivariance property to temporal permutation. It means that if you permute the input, all the feature maps, all the outputs of the layers should always be the same, just permuted. So this is equivariance. And then close to the end of your network, you put an invariant layer. Like, for example, a simple way of doing that is you take the average over the temporal dimension. And that makes your whole model invariant. And this is exactly what is done in our model. This is just a picture of the neural network we used for the challenge. And the basic building block is this alternation of spatial convolution, which is shared across the time dimension. So it does not mix different times. It just works independently time by time. And then use self-attention in the temporal direction. And self-attention, what it does, it basically computes all the cross correlations between the different time instants. And by doing so, it is equivariant to permutation, and which means that if you use this basic building block in every operator that you have in your network, you have a network that is equivariant to permutation. We also have a few tricks here and there. For example, in this turn module, we reuse some of the ideas from our DeepSum paper on ProbaV, particularly the idea of dynamic registration filters, which now we make also equivariant to temporal permutation because we want to exploit this nice property. And also we have this multi-resolution fusion stage at the end where you have 4 different resolutions that are mixed together in order to build a more powerful semantic representation of the scene. So this is very useful because we want to do segmentation. And so that's really it. This is just a sample image from the test set. And if you want to learn more about permutation invariance on super resolution problems, and actually something more in particular, quantifying the uncertainty of your model, check out our paper. It's a preprint called Permutation Invariance and Uncertainty in Multitemporal Image Super Resolution. And thank you.
We have actually a question from Joan from Airspace, who is wondering, would your solution work well when order matters? Maybe adding some positional and encoding, sorry.
Yes, there are some cases where ordering matters. For example, if you have a multispectral imager and you want to exploit the correlation between the bands, in that case, ordering does matter. So you might want to use operations that rely on ordering, like 3D convolution, or even self-attention with a positional encoding, as you suggest, as it is standard in transformers, for example. So yes, there are some cases where ordering does matter. It's not the case of when you take images from different days for multitemporal series.
Okay, Many thanks. I think that we're a little bit late on the schedule, so it's time to move on. I'd like to thank again all the participants for this challenge. So I feel it was a very successful one with a very nice data set, a great challenge with the detection of feature at 2.5 meters from Sentinel-2, a great fight for the first place up to the last moment. And I hope that you all enjoyed participating to this one. And I'd like also to thank the partners, the sponsors, and all the organizers. Thanks. Over to you, Anne-Catherine.
Thank you. Indeed, congratulations to all of the winners. And for those of you who have gotten an appetite for doing the challenges after seeing what the prizes are, you will be pleased to know that there are two more challenges that I want to announce. One of them is the AI for Food Security Challenge, which has just been launched, and where the goal of the challenge is to classify crop types based on time series data from Sentinel-1, 2, and Planet Fusion monitoring data, because this challenge is actually organized by Planet on the AI4EO platform. So it's a third party who came with an idea about a challenge that they wanted to run. They're providing us with the data, with some exciting prizes. So if crop classification is something that you're interested in, there are two different tracks that are available. Both will exploit the temporal dimension for improved crop classification within season, but also in between seasons, in between years. And the idea was from Planet to showcase also their daily Planet Fusion monitoring data to allow for near real-time monitoring of crops and crop growth across the globe. And to then also see in an open science way how deep learning techniques can leverage the temporal dimension, and especially a temporal dimension that is at such a highly revisit rate as a new challenge for the Earth observation and the AI community. They have partnered up, Planet has partnered up with the Technical University of Munich, the German Aerospace Agency, and the Radiant Earth Foundation to provide a unique challenge to combine data from Germany, from South Africa, and then to host it and to be empowered by ESA's AI4EO platform. As I said, it has just launched. It's still open until the 19th of December. You can find any information and register for free on the platform.ai4eo.eu and have a look at some exciting prizes that come up. If you have more questions or want to know more, next week, Tuesday, at 5 p.m. Central European Summertime, we're organizing a webinar together with Planet, TUM DLR, and Radiant Earth to give you more in-depth information about the challenge. So we hope you're very interested to join this challenge. But that's not all, because we have one more challenge that is coming up in January 2022, which we're hoping that we can all get you excited for already. So you read that right. Make an application, build an application, and put it on board FISAT2. Nicolas, do you want to explain a little bit more?
Yeah, sure. Indeed, this challenge will all be about FISAT2. Well, FISAT2 will be due for launch by end 2022. So about, let's say 1 year from now. This is a project led by Open Cosmos for the platform, CGI, let's say, for the software, and we have also this AI VPU stuff integrated by Ubotica. And then we have some application providers, Simera, Seya, GeoK, and KP Labs. Next, please. And in essence, I mean, FISAT2, maybe you could hear about that during the Phiweek session, but that will be a multispectral sensor providing data at 7 bands in the visible and near bands. This band actually will be very similar to the one of Sentinel-2, and the ground sampling will be close to 5 meters. And on board, we'll have this AI processor, here an Intel Movidius Media 2 VPU. So the idea of FISAT2 also is really to make AI app very easy to develop, such like you have the data with a smartphone. So really anybody will be able to develop his own application, and at the end with the capability to be run on board. So anyway, to get more information about the FISAT2, I encourage you to look at the recording session of the Phiweeks. There was a specific session on FISAT2 actually. So stay tuned early 2022 for this one. It will be an open challenge on FISAT2. The winner actually will have the possibility to have his application running directly on board the satellite. So more information will be provided by the end of this year and surely in January 2022. So stay tuned and look at the website ai4eo.eu. Thanks. And I think this is the time to wrap up this session. I don't know if Anne-Catherine, you want to do it. At least on my side, I mean, here with the AI for EO ambition is to bring the two worlds of AI and EO all together. So we like to encourage interaction and collaboration. I hope you enjoyed this session where we explore the wider potential of AI-based solutions for EO through the master student with BIS Cambridge and the AI for EO CDT. We have the Copernicus framework with the AI for Copernicus open calls. We have finally the AI for EO challenge. We have awarded the winner of the second challenge. We have just started a new challenge with TUM, Radiantors, Dealer, and Planet. And finally, we announced this FISAT2 challenge for early 2022. So yeah, on my side and Isa Philip, we'd like to thank all the speakers, organizer, and all joining this session. I don't know if you'd like to say something else, Anne-Catherine, but on my side, I'd like to, yeah, thanks again.
No,
Over to
thank you all. Thank you all very much for attending.
So have a good evening and see you soon.